Definite integrals are integrals from a set point to a point in a closed interval of a to b. It uses the fundamental theorems of calculus 1 and 2. And part 1 states that if f of x equals a to some number of f of t of d of t, then f of x is going to equal f of x. And you're probably thinking, what just happened? What you just need to know is that if it goes to some constant, and a can be any constant, but if it goes to any variable, you just plug this variable into here. And what they're going to give you is something like d over d of x of 2000 2x of f of t of d of t. The answer is f of x. You just plug that in there because these two variables need to match. But if they give you something like d over d of x 3 2x squared f of t d of t, what you need to do is you are going to plug that in there. You're going to get an f of x squared, correct?
Mm-hmm.
F of x squared
times 2x
times the derivative of that, because it is not equal to that.
You have to get it to the same power at all times.
The same power no matter what. So that is going to equal 2x. And that is the fundamental theorem of calculus.
Part 1.
Part 1. And if I look right here, actually, the thing is that it doesn't even have to equal the power. It needs to be exactly like that. If it has 2x there, you still have to take the derivative of 2x, which will become 2. But whatever f of x is, you're just going to plug in x squared for there. So for a good example would be 5 to, so d over d of x, or 5 to x squared of 1 over 2 plus x, or t, of d of t. That would equal 1 over 2 plus x squared, and the derivative of that, because it's not equal, 2x. And then you can just do it from there. And that's basically the first fundamental theorem of calculus. The second fundamental theorem of calculus basically states that if f of x equals something equals a to b, this is part 2, a to b of f of t, or f of x, my bad, d of x, that is also equal to f of b minus f of a. And this is actually the main thing you're going to do, because this is mainly what definite integrals are built around. Not this is barely used, but this is mainly used. Because if I give you something as like 3 to 5, 2x squared plus 2 dx, what I'm trying to do is just get the antiderivative. I mean, do the antiderivative of it, which is going to give me the derivative. And I'm going to figure out how much area is below the curve to the x line, or some other curve, and that'll be something more and more, that's a little bit more advanced than what we have right now. But that's basically what they want to know, is from 5 to 3, what is your answer? So what you're going to do is you're going to do the same thing you've been doing. You're going to get 2/3 x cubed plus 2x. And let's make this 0 to 5. And then what you have to do is you put this line 0 to 5, and you're going to do the top minus the bottom plugging in. 5 cubed is equal to 125 divided by 3. Have no flipping idea. So whatever 5 is minus 0, 0 is going to be nothing. So whatever this is multiplied by 5.
Plus 10.
Plus 10 is going to be your answer. So you're going to have 250 over 3 minus 10 as your answer. And
plus 10.
Oh, my bad. Plus 10. But normally be minus 0. Whatever this is, the bottom is 0.
If it was like from 2 to 5,
you'd have to plug in 2 and subtract that whole answer.
And then subtract 250 over 3 plus 10
minus the whole thing
integral of 2, whatever that may be, which would in this case would be 16 over 3 plus
2, which becomes minus 16
plus,
over 3
4
minus
plus
4. So that's basically the end. That's part 1 and 2. I hope you learned something, and good luck on your AP exam.